Welcome to the Basics of Boardwalk Design. My name is Jonathan Dove. I'm a project consultant with Permatrack, and I'm going to be the moderator for today's webinar. Thank y'all so much for attending. We're excited to talk to y'all this afternoon about Boardwalk Design. Just a couple of quick housekeeping things before we get going. We have this webinar set for right at an hour, so we're going to do our best to wrap this up at the top of the hour. So just with that being said, we have the entire audience muted. And so as we go through the presentation, if questions come up that you'd like us to address, we have about 10 minutes left at the end of the presentation, essentially, to try to tackle as many questions as we can. So if you'll drop your questions in the chat, I'll aggregate those as we are going, and I'll get John and Jason to help us out with the answers at the end. So with that being said, Jason Philbin is the president of our company. He's going to be our first speaker today, and then John Powell is our vice president of sales, and he's going to be handling the back half of the presentation. What our schedule looks like, we're going to just address boardwalk planning and design at a high level, and just talk about the things that you really should be considering for boardwalks, and then we'll get into foundation selection, material selection, and kind of go through the different options associated with that. And then we'll run through some case studies at the end to just kind of review different boardwalk applications, what you can do to enhance your projects as you're going about different design work. So with that being said, I'm going to hand it off to Jason to get it started.
Yeah, thank you, John. Jason Philbin here. Like John said, I'm the president of Permatrack, and I wanted to say this just to start off. What if you left this webinar after 1 hour and you sat back and you thought about what you have learned and listened to, and you said that you did learn at least one thing about boardwalk planning and design? If you take one thing away from this webinar, then I think John and I and John Dove have accomplished our objectives, and that is to give you the basics of boardwalk planning and design. And so with that, we'll get right into it. I've got a lot of slides to show you, and John Dove is going to be advancing the slides for me. So it all starts with deciding, where do you need to put a boardwalk? And I'll say this, if you're a trail designer or a greenway planner, you know that one of the more expensive items on your trail greenway is the boardwalk. The boardwalk is a costly item, so you want to minimize the length of the boardwalk as best you can. Bridges and boardwalks are going to be the big cost items on trails. I've seen that over and over through many of the bid forms that we've looked at. Now, this is a real example in Atlanta, Georgia, that was built several years ago. And what you're looking at here is a designer's plan. They were challenged with taking it from point A on the left to point B on the right. They needed to build a trailhead on the right, take the boardwalk through a wetland, and then tie it into an existing trail on the lower left-hand corner of the trail. And this is very, very common. Step one is, where do you absolutely have to put a boardwalk? If you can do a trail on grade, easy decision, do a trail on grade. It's going to cost you less money. However, the EPA and the Corps of Engineers, they're the regulatory bodies. They have some rules that you must follow if you're in a delineated wetland area. And it all goes back to 1972, when, if you're aware of or have heard of the Clean Water Act, the Clean Water Act in Section 404 provides some permitting guidelines and regulations and what you can or can't do inside a wetland. Particularly, it says that they discourage putting fill into the wetlands. Therefore, the need for a boardwalk. The trail has to become elevated. The boardwalk is nothing more than an elevated trail in a wetland. Now, the boardwalk doesn't eliminate all impacts to the wetland for sure, but sometimes you have to take into account the shadowing effect of the boardwalk. You have to take into account the footprint of the piles that you're putting in the boardwalk. So consideration into pile diameter, pile spacing, horizontal and longitudinal spacing all comes into play. So a boardwalk is a good solution. It doesn't capture all of the concerns of the Section 404 permit, but it certainly addresses many of them. As you can see here, where the delineated wetland is in the green, that's where the boardwalk is. And they tried to minimize the length of the boardwalk by keeping the cost in play. Once you have decided where the boardwalk goes, now you need to decide, how wide does the trail need to be? So Some of the things I've seen designers think about are when you're determining the width and what the typical section is, think about your vertical and horizontal clearances. And this picture illustrates some obvious clearances if you've got obstructions like signs or trees vertically, horizontally, but also think about your bridge clearances. I've seen trails go under bridges where the clearance is a minimum needs to be 8 feet. Think about a cyclist on a bicycle going under a bridge and you're taking a trail under a bridge. Or think about a trail going under an overpass where the owner wants to run a fire truck or an ambulance. You have to take that into account. Think about possibly how the boardwalk or the trail is being built. Do you need to deliver material down the boardwalk and still find your way underneath these obstructions? Those all go into play in determining what that typical section is. And I can tell you from experience, most commonly we see a 10-foot wide trail or a 12-foot. Those are the two most common ones. More recently, in the last 3 or 4 years, I've seen trails go as wide as 14 feet clear and even 16 feet clear. So thus you'll see in some of the slides that we present later on, you'll see some sections that are really quite large. Instead of 5-foot boardwalks, 6 feet boardwalks, we're now into trails that are 14, 16 feet in clearance. So all of that has to come into play. Think about, are you running opposing traffic like cyclists? Is this just pedestrian? Or are you trying to run emergency vehicles down the trail? That will decide how wide your trail needs to be. So let's go to the next slide, John. And then one thing specific to boardwalks is defining what we know as the clear width. And if you've ever talking with a boardwalk designer, whether it be Permatrack or some other boardwalk engineer, one of the first questions that you'll get asked if you're the designer, what is your clear width? And the clear width is simply your available walkway width within the boardwalk. As you can see in the picture on the left, from the grab rail to the grab rail, the clear distance is measured from those two obstructions. It could be a bumper rail or a tow rail on the bottom of the curb if it didn't need handrails. So think about those side-mounted obstructions. And the clear width is important because the actual boardwalk width may be wider. In the case of a prefabricated boardwalk system, the boardwalk has to be wider so that the railing can be supported on the top, and it increases the width of the boardwalk. So for example, with a concrete boardwalk system, we would take the clear width and we would add to it about 15 inches to allow for a railing like you see in this picture, or for a tow rail or a bumper rail to be top mounted onto it. Because what we're trying to avoid is what you see in the right-hand side picture is a narrow bridge. You certainly don't want to take your trail and then neck it down when you get to the bridge and then widen it when you come on the other end. We have made that mistake. We've learned the hard way, but it's good advice to take your trail width and make it exactly the same as the clear width on the boardwalk. At least no narrower on the boardwalk than the clear width matching the trail. So let's look at some of your material options. So once you've decided now where the trail goes and what the width of the boardwalk is, what are the different materials that are available to you? Well, we'll start with a concrete boardwalk system, quite simple. The foundation system supports 2 beams that run longitudinally from pier to pier, and then perpendicular to all of that is a tread. Precast concrete tread sits on the top of that. So those 2 components form the superstructure of the boardwalk. Prefabricated boardwalks allow the manufacturing of the boardwalk to take place while the foundations are being installed. A very good use of time. Efficient way to build a boardwalk if the timing of a boardwalk is of importance to you or to your client. Next slide, John. Specifically with a precast concrete boardwalk, you'll hear terms like abutment, a precast abutment, and that's just simply the beginning point of the boardwalk. So there would be typically 2 abutments, one on the beginning on the left, one on the end on the right-hand side, say. There could be precast piers like you see in the top right corner in orange. It could be a stackable precast pier system, and we'll get into what that can look like with some real pictures here in a few slides. Also in orange are the stringers, or what we call the beams. The beams would run from pier to pier, and with a concrete system, the strength inherently allows you to really expand those lengths. And instead of normally being limited to, say, a 10-foot span, a concrete system can certainly take you 20 feet and beyond. And we've even seen where systems out of concrete can be made 30, 40, and even upwards of 50 feet in span length. So think about that original slide we showed you about where you put the boardwalk and what the impacts are to the wetlands. Think about how fewer piers is less impact, right? So that can or may become important to you. And then lastly, the perpendicular component, or the surface that you're walking on, is what is referred to as a tread. That is the plank, if you will. If you're familiar with timber boardwalks, that would be the plank. It would simply be a plank of concrete. And then typically a curb or a railing would be set on top of the system. So that's a concrete boardwalk system. So let's go to what you've probably seen more of. This is the old tried and true methodology of building a boardwalk out of wood. There's been many, these have been in systems for hundreds of years. They've been built, and that's sort of the first type of boardwalk system that comes to mind for many designers. And a timber boardwalk is exactly that. Everything is made out of timber. The piles, the cross bracing, the header going from left to right on the piles, the stringers are the longitudinal members. As you see the tall in the picture on the left, you see the stringers running from header to header. And then the railing, of course, can be made out of timber there also. Now, the limitations of a timber boardwalk, is that typically they're limited to about a 10 or a 12-foot span. So you think about, again, your impacts to the wetland. Can you handle those type of impacts? And because timber is not as strong as the concrete, then you may get more diagonal struts. You may get some blocking. You may get more members. There's certainly a lot more parts that go together in building a timber boardwalk. The advantages are many a times it's going to be quite inexpensive. The parts are readily available. You can go to Home Depot or Lowe's to get these parts and pieces, and they can come together. And it's sort of a method that's been tried and true. And many contractors are familiar, very comfortable building these types of boardwalks, and they've worked well for years. So, and let's go to the next slide. Another type of material that's come on the scene, I would say in the last 20 years, is a composite pile. And I'm showing you 3 different material types. There are many others, but composite boardwalks can be just that. It's a fiberglass type system. The piles, the stringers and the headers, the cross section might look very similar to a timber boardwalk, but the walking surface would also be made out of a composite material. You may be familiar with like Wagner's material, or you may be familiar with the Trex product. Those are just 2 composite materials that I've seen out there in the world doing boardwalks. A lot of times the decking of a composite boardwalk is used with a timber substructure, so you're combining the 2 materials. Those are the 3 most common that I've seen. I've also seen some metal grading systems that work well if you're looking at reducing the shadowing effect of boardwalks on a wetland. If you need perforated holes on the top, a metal grading system could work well. So there are other options, but these 3 that I've shown you are the most common ones. So once you had chosen the material, now you're ready to get into the nuts and the bolts and figure out how to design the boardwalk. So the bad news is that a boardwalk, for us engineers, and I'm an engineer, we like to follow rules and regulations and see exactly how to design a boardwalk. That's not the case. Boardwalks have not found their way yet as their own guide in the design codes. But a boardwalk is typically considered a pedestrian bridge. And as a pedestrian bridge, then we have a very nice guideline. These 2 booklets on the left are 2 design guidelines that really speak well to how to design a pedestrian bridge, which as an analogy would be a boardwalk. You can think of a boardwalk as a series of many pedestrian bridges. The guide on the left-hand side, if you're a highway bridge engineer, is the LRFD bridge design specifications, more commonly used by transportation or highway engineers in designing large vehicular bridges. The image in the middle is the LRFD guide spec for design of pedestrian bridges, and that specifically is for pedestrian bridges. It's much thinner, a thinner booklet than the one on the left. The pedestrian bridge has a lot of references to the Astro Bridge Guide. So if you get the pedestrian guide, you're probably quickly going to be referring to a lot of what takes place in the image on the left. So the 2 on the left are the ones that are typically used for pedestrian bridges. But again, boardwalks are not only used as pedestrian bridges. Boardwalks sometimes can be connection points between buildings. Say it could be a connector between two buildings. So or it could be used as an observation platform or a stage or a gathering platform, a viewing platform, and they could be now parts of buildings, right? You probably have examples like that. And that's where the IBC, the International Building Code, comes into play, because now that refers more commonly to bridges. To buildings. So we find ourselves using all three of these codes as boardwalk engineers. I would say 90% of the projects that I've been involved in fall on the guidelines on the left, while we may get about 10% with the IBC. Going further into the pedestrian guide, I've taken what I think is most important. If you're a structural engineer and you want to know what is it that I'm designing for, as a structural engineer designing a boardwalk, you have to consider two vertical loads. First one is you have to look at a uniform pedestrian load. And if you're using the AASHTO code, it's going to be 90 pounds per square foot. And the second loading is a vehicular load. And the vehicular load is going to be a function of how wide the boardwalk is. And you don't have to consider uniform and vehicles together. It's one or the other, whichever produces the most, whichever controls the design. But let's look at the vehicular loading. If your boardwalk is 7 feet or less, and this is coming right out of the pedestrian bridge guide, if you're 7 feet or less, there is no requirement for a vehicular load. Now, standard practice has been to design it at least for what you would expect to go over a very narrow boardwalk. I would expect a small gator or something fairly light, a light vehicle to go over the top. So we would design a boardwalk for no less than a 5,000-pound gator, say, running over the top, which is really a heavy gator. If your width is between 7 and 10 feet, then you're required to design for what they call the design vehicle of an H5 truck. An H5 truck is pictorially shown right there with their axle loads, but it's a 10,000-pound total load on the truck. If you're bigger than 10 feet, so like I said, 10, 12, 14, 16 is very common. Commonly now, the bridge and the boardwalks are being designed for H10, which is a 20,000-pound vehicle. Now, the third vehicle that's not listed on here is any owner-prescribed vehicles or construction loading. Sometimes they govern the system. So maybe the owner wants to run maintenance vehicles down the boardwalk, or maybe they want to put a fire truck or an ambulance on the boardwalk. And that very often is the case. They want access to some of these special vehicles, or maybe the installer wants to run some construction equipment over the top. Maybe it's a concrete mixer. Maybe it's an excavator that's being used to install part of the trail down the boardwalk, or maybe it's being used to install the boardwalk itself. Those very often can exceed the vehicular loading that you see in front of you right there. So those are good loads. That's a quick summary of the vertical loads from an AASHTO standpoint. What I can say about IBC does not declare what the vehicular loads needs to be. Rather, think about it from a building standpoint. They look at what the usage is of the floor plan that's being designed. So you'll see very commonly in the boardwalk world, if IBC is governing, anywhere from a 60 to 100 pounds per square foot. And the picture that you see right there is demonstrating what a 100 pounds per square foot looks like. So think about if you're in an elevator and you're very crowded, sort of like what you see there, that's approximately what 100 pounds per square foot might look like. You can imagine if you have an observation platform that's being used for a concert or a stage, the floor loading may be bigger, and you could be pushed as high as, say, 250 pounds per square foot per the IBC if you were of certain usage classifications. So it can be heavier. Both generally lead you to about the same answer, but there are some nuances you need to know about each one. Okay, and then the next, so that covers vertical loads, lateral loads. There's several different lateral loads to consider. The first one, real quickly, is the wind load. The wind load quickly takes you to the ASCE maps that give you the wind speeds and the formula you see there. But most of the country is governed by 115 mile per hour wind speed. You see on the coastal areas, the speed gets as high as, say, 180. However, there are isolated areas in the peaks of the mountains where the special wind areas, for example, in Pikes Peak, we were asked to design for 170 mile per hour winds at the top of Pikes Peak. So certainly that is not 115. So those can be very, very critical for uplift as well as lateral loads. So you do need to consider lateral loads. Typically, the wind load is going to be the governing lateral load, not only to the system, but then it also has to transfer down to the bottom to the pile in the foundation system also. Another lateral load is seismic loading. We get asked this question quite often. And yes, seismic load sometimes does govern, as you can expect, probably only in those red areas where there's high seismicity on the West Coast, down in the Charleston area in the Southeast, certainly in Hawaii and around Memphis. That is going to be left up to the structural engineer to decide, does the seismic load, how does that compare to the lateral load? And the one is going to govern over the other. And other loads that we've seen take place that need to be accounted for, braking loads. Boardwalks generally are going horizontally around curves. They could be going up and down a hill. So if a boardwalk is subjected to a braking force that exceeds the lateral load, that's going to be your controlling load. Typically about 25% of the design truck load could be imparted into as a braking load, and that would transfer itself down to as a lateral load on the pile system. Snow loads, certainly in the higher elevations, is critical. This top right picture is in South Lake Tahoe, and we were required to design for 240 pounds per square foot loading, which is significant snow load. And that's serious loading, especially for that bridge in the middle, as you see spanning from one boardwalk to the next. That certainly could control the design, and it probably did for the truss bridge. It definitely did control for the boardwalk that you see on the near side of the bridge. Water, submerged boardwalks. Boardwalks are in wetlands, boardwalks are in floodplains, and you're going to have this hydraulic force, this hydraulic loading, not just submerged, but velocity of flow coming from one side, pushing on the boardwalk, and stream debris. So those are some things that need to be considered also. And lastly, not to be ignored, is temperature loadings, temperature effects. As the temperature goes from one gradient to another, that causes some movement in the components of the system, and the system needs to be designed to account for that. That's best handled by proper detailing in the boardwalk itself. These load combinations, now I know there's a lot on this screen for you to look at, and I'm not going to explain all of those numbers, but just know that if you're referring back to the AASHTO Bridge Code, if you were a bridge engineer, you would be looking at most of these load combinations. And the AASHTO Bridge Code says that, hey, for load case number 1, you need to have this load factor for this type of load plus a dead load times this load factor. And it has all of these combinations of load factors, load combinations that have to be considered for a vehicular bridge. For a pedestrian bridge, it's made a lot simpler. Some of these categories simply just do not need to be accounted for, and that's explicitly stated in the pedestrian bridge guide. So the one thing you need to remember is there in the box. Your load combination that needs to be looked at is a 1.25 times your dead load plus 1.75 times your live load, and that's strength number 1 in that chart. That's a 25% increase on your dead load and a 75% increase on your live load, and that becomes your design load that you have to do for your boardwalk. Now, once you have decided what your loads are, now you have to start designing the materials themselves. And going back to some of my structural engineering classes, from a reinforced concrete design, since that's one of the materials we're looking at, reinforced concrete is designed as a rigid beam member, as a load sits on top of the board, sits on top of the beam. The top portion is in compression and the bottom is in tension. And that's why the heavier reinforced part of the boardwalk is steel is added to the boardwalk to take those tensile loads. And typically there isn't much needed to handle the loads in the compression zone. So the concrete capacity of the beam is then computed by the formula you see on the right-hand side. It's a function of a couple of things: the amount of steel you put in the beam in the tension zone, plus the geometry of the beam itself, so the width and the height of the beam. So a concrete member has the flexibility of allowing themselves to adjust to the loading. So the width and the height and the amount of steel can all be variable, right? So these are typically made to fit to whatever the design loads are. Now, the next slide shows a timber member, and it's still a beam design where you have compression on the top, tension on the bottom. But typically in the timber design, there's typical sizes, right? You've heard of 2x4, 2x6, 2x8. These are typical sizes that are available in hardware stores. And so those are the members that are trying to be used to form the timber design. Now, the disadvantage, that's a great advantage. You can use readily available sizes, but the disadvantage is they're typically tall and slender. Think about the wood framing in your attic. You've seen, if you look at those wood framing members in there, they're probably going to have a lot of blocking and cross ties and diagonals to support those because they simply can't span that far. Like I said earlier in the presentation, typically a 10-foot span for a boardwalk is about as far as you're going to take some of these stringers. So there's a limitation on span, but there's a benefit of having the ability to go get these pieces readily available. And then the third material that I'll show you is the composite design. And this is more of a black box for us structural engineers. You'll find a lot of different shapes, solid ones, scalloped or hollow ones. These are three commonly used decking products that I've seen for boardwalks. And the specific manufacturer, and like I said, Trex is one of them, the capacities of these materials is going to be listed by the manufacturer because the components of what goes into the exact fiberglass product is going to be specific to the manufacturer. So only the manufacturer would be able to tell you how to design or what those capacities are. So those become a matter of pulling load capacities from a chart by the manufacturer. Now, the last slide before I get into foundations is probably the most important slide of the day from the ones that I'm presenting to you. The specifications. If you're a designer, if you're the owner, you got to get this right. You got to get this right in your project documents if you're preparing those documents. Number one, as a set of good specifications is going to prevent a clear outline of what it is you and the designer are trying to accomplish, properly detailing where the boardwalk is, properly detailing what the boardwalk consists of, what the alignment is, what the foundation system is, foundation depth, providing all of those so a contractor can clearly give you what it is you're expecting from this project. A good set of specifications is going to ensure product fair competition. You would, of course, lay out what the minimum requirements are and then allow potential alternates, but basically meeting certain requirements. You've probably heard of performance specifications being mentioned before, or a basis of design terminology. And those are ways for you as a designer to show your design, your best design that the owner likes and approves. Show your best design, but there may be some other ways of thinking of how to solve this, but that would come in as an or equal to a defined set of construction documents. And then, of course, it protects you and it protects the owner from an installer or from a bidder, potentially from proposing an alternate that is not an equal to what it is that you and your client want. And with that, I'm going to move into foundation selection because as you think about a boardwalk, as I said on slide number one, a boardwalk could potentially be the most expensive portion of a greenway trail. And inside the boardwalk itself, there are four components you need to think of: foundation, boardwalk material, the labor that it takes to install the system that you've selected, and then the railings or the curbs that are going to be added to the boardwalk system itself. So those are four things. Number one, you got to get the foundation system right. The foundation system could be your most expensive decision within the boardwalk itself. So step one is to get a geotechnical report. We would always recommend that you get a geotechnical report. I have seen projects where they have elected to not get a geotechnical report, and it hasn't gone well for them. But when you do get a geotechnical report, those several $1,000s can be money well spent. A geotechnical report is going to require that a geotechnical engineer and his team go out to the job site, potentially do hand augers, potentially do some soil borings, extend down into the soil layers to some described depth, and then analyze the soil. And the soil will be analyzed and quantified, and then from that, a foundation recommendation will be made. And as you'll see from some of the future pictures, you want to match up the loading of what it is you're designing with the soil. So there are definitely foundation types that really don't make a lot of sense for the soils based on what the geotechnical engineer in the report says. Without a geotechnical report, you're simply guessing on what the foundation type should be. And it certainly just provides for a smoother process from beginning to end and helps protect your client from excessive change orders down the road and delays. Now, foundation selection. I've listed what I've seen of probably 8 or 9 different types of foundation system, and we've listed them from top to bottom, the top being your least expensive to what we have seen as being the most expensive. And there could be some of these could be shifted 1 or 2 spots, but generally it follows this top to bottom approach. A precast pier system is considered a shallow precast foundation system like you see in the top left picture. A cast in place spread footing, you're probably very familiar with that. It could be a square, it could be circular. Timber piles are very common. They're very readily available. Certainly in the Southeast, we see a lot of that. Concrete piers are very common. And by a concrete pier, I'm not talking about a driven pile. That comes later, but a concrete pier could be a sonotube extended down into the ground with steel and concrete poured into the forms to form a circular pier. Steel helical piers, like you see in the bottom left image, steel helical piers are very advantageous, and they're quite inexpensive when the soil is right. Again, the geotechnical report is going to tell you if you should or shouldn't be considering helical piers. Composite piles are coming on strong, definitely in the south central part of the country. We've seen composite piles be used, and those are nothing more than circular fiberglass pipes. They're being used and extended as circular pipes. And then drilled shafts. Drilled shaft is another word for that is a caisson drilled into the ground. It's very common in the south central part of the U.S. And then the last two, a driven concrete pile, a driven steel pile. And I'll talk about why those have become some of the more expensive foundation types. But let's go to the next one. I'll start with shallow foundations. So here's the shallow foundation option, probably your least cost effective, not going to be very applicable to maybe a wetland environment per se, but on boardwalks where you have upland soils, a precast footing could work just fine. These would be a stackable component system. The top component in the middle of the screen could be repeated 2, 3, 4 times on top of each other to extend the height of the pier. So this is just a stackable precast foundation system. Cast in place concrete footings could be circular, could be square. You're looking at a circular one here that's just extending down to frost depth, could be extending, say, 12, 18, 24 inches. And it could just be that, just could be an augured hole, or it could be just a hole held open with a sonotube form out of that. So simple. So now deep foundations. I'll start with the timber pile system because that's the most common, certainly the most common that we see here close to where I live in Charlotte, North Carolina. A timber pile system is a good, inexpensive foundation system, typically driven, could be vibrated into place. Fairly light pile system could be installed with an excavator. Doesn't always require a hammer and a drill rig. So it could be done with a lighter equipment if needed. So that makes it desirable. Readily available makes it desirable. Inexpensive makes it desirable. Durability is where it potentially could be a negative. Next system is a fiberglass pile. I mentioned the brown, that's a fiberglass composite pile system. There are several fiberglass suppliers who do this, and these are pile systems that have been used for they started their industry in the marina environment, and they were used for bumpers at bridge piers and they bollards, if you will. And now they found their way at being used as piles, and they can be driven. They're going to be fairly light. They have a tremendous load, vertical load capacity, and they can be driven into the ground, because think about what they're using for. They're not being used for extremely heavily loaded bridges. They're being used for boardwalks, and the load capacity matches up very well. The load requirement matches up very well with the capacity of a composite pile. And drill shafts, like I said, drill shafts in the southeastern part of the U.S. has been, or south central part of the U.S. has been very common. Drill shaft is nothing more than augering a hole to some prescribed depth or design depth, and then either casing or uncasing the hole to keep it open, and then placing a rebar cage of steel, and then filling that void with concrete and extending it up above the grade to some elevation that's needed for the boardwalk. So a good long-term solution, and may in fact be required in some situations. Driven steel pile, and I've got 2 slides, and then then John Pyle will take over. But a driven steel pile sometimes is required. The capacity of a driven steel pile and as a driven concrete pile is far too much for what is needed vertically for a boardwalk system. Boardwalk loads are going to be typically 5 ton, 10 ton, maybe 20 tons. And these type pile systems, you might typically see these on highway and vehicular bridges. And you might say, well, why in the world was it used here on this particular project? In this particular example, it was used because of the large thick layer of poor soil, and they needed something that could be driven through that layer down to a hard layer that was, in this case, about 40 feet below the ground level that you're seeing there. Sometimes it's the only option that can go that far. So a driven steel pile, and then the next slide, John, is a driven concrete pile, or one more, John, is a driven concrete pile. And you can tell from the size of these that they're just large, and the capacity of these piles don't match up very well with the load capacity, load requirement that's needed from a boardwalk. So with that, let's go to the next slide, and John Pyle now will take you into some of the features and the add-ons that are typically considered with your boardwalk.
Thanks, Jason. Yeah, so kind of following that design process, so you've selected a boardwalk material, you have your foundations known, so you can then move on to making the decision of whether or not you need a handrail or a curb will work. So that decision is typically going to be driven by how high above the adjacent ground your finished boardwalk surface is. In general, if you're less than 30 inches above ground, you don't need a handrail. So you can use either a curb, as you see here, or you don't have to put anything at all. You have that option. The curb, though, is oftentimes used just as a safety measure to keep people from accidentally stepping off of the boardwalk, just to keep them in kind of on the path. So then you go to the next decision is if it is higher than 30 inches. So now it's a handrail. So the height of the handrail that you choose will be determined by the general use or the most prevalent use of the boardwalk. So if it's pedestrian use mainly, it'll be a 42-inch high rail. If you're expecting a lot of bicycle traffic, then that typically the height is extended to 54 inches. And so once you know your height of your rail, then it's which code are you going to design by. And as Jason mentioned, there's a little bit of difference between AASHTO and IBC. The big difference to take away is if you're using AASHTO, so both codes will apply a 50 pounds per linear foot force at the top of the rail, as well as a 200-pound force has to be point load is looked at. The difference is that plus or the or. So in AASHTO, you have to put them together. In IBC, you look at both of them kind of independently. So the results are a little bit different. And with that information, then you would determine the connection required, either a 2-bolt or a 4-bolt kind of a connection to put that post connected to the boardwalk. And so once you've gotten your design there, codes decided, now it's the fun part comes into, you can start getting creative with what type of railing is going to best suit your application. So you can now start looking at the aesthetics and how does it fit in with the surrounding environment, or what does your client or the owner prefer. So there are a lot of different, you can generally use any type of material that you choose, but you want to be mindful of the cost implications of your handrail choice, as the next slide will show just a high level look at how the cost can vary from the most economical or least expensive being a timber type of railing, which might be in the $50 to $75 a linear foot range. But when you get into some of those stainless steel cable systems that look really nice, and they limit the kind of obstructions that you get from your railing, but those can often run beyond $300 a linear foot for your railing. So oftentimes the railing can be right up there with the foundation as being one of the biggest cost drivers of your overall project. So you kind of want to be mindful of that, and as you're going forward and setting your budgets. And then the next thing that needs to be considered is how will the boardwalk be constructed. So there are a lot of different factors that come into play that would determine that. It would be things like the environmental permit conditions. You may have some limits on the site, or there may be some nearby buildings that are going to limit access. So there are basically three different ways or three different approaches to constructing. So you have what we would call a traditional, where you're building it from the ground, and that's what this photograph here shows, where you're able to have just normal equipment, drives right up to next to the boardwalk, installs everything. You're able to work from the ground. It's the most cost-effective way to do it, as well as the quickest way. However, when you have some limitations like permit conditions or other site constraints, now you may have to consider building it either a partial top down, where the foundations are built from the ground, and then the boardwalk is built from the top, or a full top down, where everything is done, if the foundations and the boardwalk are all built from the top. So taking a little bit closer look at that top down, the next slide shows you an image of what we mean by top down. So in this case, you have the equipment that is operating on the boardwalk. Here it's showing a vibratory installation of a pier. The important thing to notice, though, is that when you are installing piers from a boardwalk, you are going to be limited to about a 10 to 12 foot span. So you lose some of that advantage of being able to go with longer spans in some cases. You're also limited on equipment size. You really can't fit a large piece of equipment that you might associate with a pile driving operation. Those are just too big physically to fit on top of a boardwalk. So there are some limitations there. And we do have some resources on our website. We have a number of articles that take you through top-down construction, a couple of different videos. I'll show you just a quick couple of seconds of a video to show, again, visually what a top-down looks like. In this case, it was partial top-down. They installed all the helical piers. They actually went in and as-built surveyed those piers, gave us the survey results. We checked our beam layout, adjusted it as we needed, and then they installed all the precast from the top. It allowed them to have the least amount of impact on the surrounding wetland, because this was going through a sensitive wetland area, and they really didn't want to impact it any more than they had to. So going on here next to the next slide, you can go on to the next section here, John, on material selection. So when you look at your options, there are generally three different types, as Jason mentioned. There are some others. There are steel systems that you can utilize, but primarily we see timber, composite, and concrete being used most often. And so these are the things you need to take into consideration. And I'll talk a little bit in depth of each one of them. So if you go to the next slide, you'll see a slip resistance. So there is an ANSI test protocol that can measure the slip resistance, or the coefficient of friction for the walkway surface. And so we have a summary of the results. A third-party testing firm tested several different Permatrack textures, as well as wood and composite, The important thing to note, there's a lot going on here, but that 0.42 line is the minimum coefficient of friction to be considered passing. The gray line is the dry test result. The blue line is the wet test result. So what you'll notice is everything does well when it's dry, but when you add water, the composites in the woods just don't perform as well, which I think we all would have seen those slippery when wet signs around wooden and composite boardwalks. Just something to be mindful of. So it's a public safety issue. And then you can start looking at ADA compliance. Again, another public safety issue. So rigid systems like concrete tend to stay in compliance, but wood and composite over time will warp and twist and then come out of composite. So if you go to the next slide, when you look at durability, so this is what we're talking about here. Composites and timbers do tend to, with the introduction of moisture and UV, they can start to warp. And within a couple of years, you can expect to have some maintenance ongoing, and then full replacements for timbers and composite. Anywhere beyond about 10 to 20 years, you might be looking at a full replacement. It just depends on the environment. Whereas precast, you can generally count on a 50 to 75 year design life with little to no ongoing maintenance. And then the other consideration would be around aesthetics. Everything looks great when it's first initially built, and can stays in ADA compliant. It looks great. Over time, you can definitely get a little bit of wear and tear on composites and timbers. With precast, you can do some things with color and texture to help with the aesthetics as well. So you have some different options there to enhance each of these, and to deliver the look that your client may be looking for. And then under environmental, there are some different things to think about here as well. With pressure treated timber does have chemicals that can leach into soils. Some to a certain degree. It's gotten better. They have changed those chemicals in the last several years. So it's not quite as bad, but it definitely still happens. Composites are a little more eco-friendly, as they are inert, but they're non-renewable, non-biodegradable, and they're not very recycling friendly. And then with precast, it's a little bit more eco-friendly when you consider there's no chemical treatments there, and the long lifespan means that you don't have to get in there and impact the site for future maintenance or replacement as frequently. Got just a few minutes left here to go through a couple of examples, so I'll go through these here kind of quickly. This first one is what we would call the kind of the bread and butter, the one that we see most often, a multi-use trail. This is a 12-foot clear width. It's about a 900 linear foot structure. In this case, it's going through some backyards of a neighborhood in Cary, North Carolina. The town of Cary has standardized around precast concrete as their preferred boardwalk material because of the maintenance issues, but they do like to use a wooden railing just to help soften the look and have it kind of blend in a little bit more. When you go to the next slide, here's a good example. We talked a lot about top-down construction. This one was built top-down. It's about 450 linear feet. It's only 6-foot clear width, which means we really had to think about the equipment that was going to be used on top of it, and the contractor had to be real careful in negotiating those terms. But it worked out very well because they didn't want to have to drain that lake to be able to work from the ground, and that lake wasn't big enough to put a barge on it. So full top-down worked really well. The next example is another common application, which is using boardwalks as an approach to a longer span truss bridge. Jason shared a picture previously of a truss bridge. This is using boardwalk through a wetland, and you see it's only pretty low to the ground. You see the curb there as well. The next example is something maybe you wouldn't think of as much for a boardwalk. So it's a variation of an observation deck. So it's an elevated system, allows people to view this as some petroglyphs on this rock, and they want to have park users to be able to view it, but they don't want them to get right up next to it and potentially damage that historic feature. The next slide shows the Pikes Peak project that Jason had mentioned earlier. So this is at a 14,000 foot elevation. There's over 45,000 square foot of boardwalk. So, this is a very harsh condition. So precast made a lot of sense. It allowed them to use modular system to get it up to the top of the mountain. They really couldn't pour concrete up there, and they wanted it to be long lasting, but we had to take into consideration a lot of those wind forces as well as snow. And then another application that we've all seen, dune crossings. Typically you see those out of wood when you go to the beach. This was a state park project in Texas. That's the Gulf of Mexico you see there in the background. So they wanted to have concrete just for the durability of that in that saltwater environment. But again, they chose to use a wooden curb, again, to soften it, just to give a little bit of look, recognizing they're going to have to replace that wood pretty regularly. And then you can also use boardwalk systems as a feature. Here you see them using it to cross a rain garden at an urban park. And then the next slide kind of shows how you can use different systems to generate curved segments. So like for precast, we like to do things nice and rectangular, but that doesn't always fit the site. So we'll use a series of rectangular with trapezoidal pieces to make up kind of a chorded segment to follow the natural curvature. And then you can also build in observation decks into systems. So in this case, like a lot of times, especially for longer boardwalks, you want to have the ability to get out of the flow to enjoy wildlife viewing. And so you can kind of create some deck and observation locations for users. And then you can also use it for a fishing pier. You've seen wooden fishing piers, I'm sure, quite often. You can do this with, in this case, it was precast concrete, but you don't think of boardwalks as fishing piers, but that's essentially what is going on here. And then you can also use them for tree root crossings, just elevating the structure, spanning over the critical tree root zones. In this case, you really want to engage an arborist early on in the process to help you identify those critical root zones so that you don't impact the trees. And then the next example was another similar idea. In this case, though, the cantilevering the boardwalk is to avoid having to put fill in a waterway. So one option would be to drive to install sheet pile walls, fill in part of that waterway area. But that has a lot of permitting issues, restrictions. It's not always feasible. So in this case, you can kind of use an elevated structure and cantilever it to limit and minimize that impact. DOTs, certainly you can use any kind of a boardwalk system on public projects. However, you're not going to find a boardwalk specification. So a lot of times what you'll have to do is utilize a special provision or a supplemental specification and then just reference back to the DOT material standards. And then the last one here that I'll mention before we see how many questions we can answer in the last 5 minutes is replacements. Obviously, as I mentioned, sometimes wood and composite, doesn't last quite as long. So, we've seen a lot of cases where we'll be used as a replacement material for using precast to replace timber. So that you have that longer lasting material, and oftentimes the cost savings and the longer design life associated with that longer design life really helps to offset that any kind of a cost that may have been incurred up front with that original structure. That was kind of a quick run through of that last section, but I did want to save some time here to try to get as many of the questions as we can.
Absolutely. Thanks a lot, John. So we have got a good amount of questions on the Q&A section here. So what I want to say, we ended a little bit later than we targeted. So it's 1:56 right now. We are recording this webinar, and so we'll be able to distribute that recording and the slides as well. So if you need to jump off, what we'll do is we'll stay on the recording and answer all these questions verbally, and then once we get done answering the questions, we'll close the webinar for y'all. That way everything's recorded. If you need to take off, you'll have it when we send these out. So just real quick, before I get into the questions, here's all our contact information. If you ever have a question, these are kind of the regions that we all cover. If you want us to take a look at a boardwalk for you, we're happy to do that. So with that being said, let's see. Okay, the first questions, we had a lot of foundation stuff. Maybe if we could get a little bit more color on top down to kind of start is, and maybe John, this is a good question for you, but when should you use top down? What are the real advantages? You know, a lot of folks were asking about protection on a wetland area and the benefits and costs of using top down versus traditional construction. How can you go about maybe traditional construction in a wetland, or you know, is it always got to be top down? What are the kind of the ideas around that?
Yeah, so I always recommend avoiding top down if you can, because it is going to be more costly, more time consuming. However, in some cases you cannot avoid it because of the permitting issue, and the permit really comes into play. You probably can obtain a permit to temporarily impact a wetland to do traditional construction. However, that involves going through a Corps of Engineer review process, and that can be very lengthy. That can be a 12 to 18-month process just to get through the permit. And then they may require that you have to do some mitigation on site or off site, pay into a wetland mitigation bank. So top down allows you to sometimes kind of expedite that process or avoid that process. I hope that answered the question. Some of the limitations around top down, I tried to mention that it does limit how far you can span if you're having to do a truly fully top down construction, just based on the size of the equipment that you can fit on top of the boardwalk, and then reach out. Generally 10 to 12 feet is going to be your maximum, and then the foundation type is going to be limited as well. Top down lends itself very well to using a helical pier, but the geotechnical conditions may not support the use of a helical pier. It could be rocky soils. There could be, you know, kind of at a shallow depth in the wetland. There could be, you know, boulders or a rock shelf that's fairly shallow that doesn't allow you to install helical piers. In that case, you do kind of have to consider that partial top down, where you do get a permit to allow temporary construction impacts, working off of mats to install whatever foundation you need. And then you can come back and install the boardwalk from the top. Again, you're limiting your impacts. You're not having to clear an entire pathway parallel to the boardwalk. So it does help, but there are some challenges associated with it.
Thanks a lot. The next question we have is kind of associated around tidal and wetland, or tidal and coastal installations. So one question about, you know, considerations for boardwalk designs along a tidal river, and then also what do you find as far as the load criteria for designing a boardwalk along an ocean front? Is it wind loading? Is it wave loading? Is it a combination? How do you make the determination there when it comes to boardwalk design in these environments?
I will try to take the river question first. So some of this are a tidal river. So part of the issue there would be the waterway, understanding the water flow, the velocities of the flow. So that's going to impact your foundation design as well as the structure design, because the moving water is going to impart a lateral load, as Jason had mentioned. So that's one consideration when you're around water. The other consideration is, if it's a salt environment, you may want to consider using epoxy coated steel instead of standard black steel. We've supplied that on a number of different structures. And then because you are around a river course, water course, you know, permitting may be an issue. So you need to think about your access. How much can you permit? I mean, impact, you know, what are your working points? What's your access? Those are all concerns. And when you're working like on an oceanfront type of an application, where you're considering what are your design concerns there, again, it's a salt environment, so you may want to consider epoxy coated steel. You may want to consider the mixed design if you're using concrete to be a little more of a durable mixed design. There's some additives that you can use there to help your durability of the concrete in that environment. Wind loading, as Jason shared that wind map, you'll have a higher wind design load to be considered on a coastal environment. But the issue of like a wave impact, there's really not a good way for that we've seen to design a structure to withstand a hurricane-driven flood surge. It's just not very feasible. So one way to do that is to elevate the entire structure above that anticipated flood elevation. But again, you're adding a lot of cost, so it may not be feasible to design for that kind of a flood surge wave action when you're on a beachfront like that. So that's a challenging environment.
Thanks a lot. Perfect. And yeah, one question around specifications. Jason, maybe you could answer this one. Just they were just asking how we get support on specifications. What kind of specifications can we provide, if any?
Yeah, thank you. I thought that was a very good question. I personally have been involved in over 600 completed projects, with more than 90% of them being publicly funded projects. Definitely would be happy to share many examples with you. They would be public documents. I'm not providing any information that is illegal to do. Obviously, it's all public information. Be happy to share some examples of that, but it certainly can be done. And I talked briefly about the basis of design of the performance specification, so you have to go through those steps that we talked about. Decide where you want the boardwalk, decide on how wide the boardwalk is, decide on the alignment of the boardwalk, set the physical parameters, and then evaluate the material by looking at those 4 components that you have to evaluate when you're determining a boardwalk cost, because of course cost is going to matter. So again, you got to look at what railing you're using or curb, the boardwalk material, the cost that you think it's going to cost to install a boardwalk system, and then the foundation system. Once you've got all of those things together, pull together a design that can be clearly understood by a contractor. And I believe one of the questions, John, was what does a consultant do versus Permatrack? What can they supply? I can speak specifically for Permatrack. Our company provides the engineering for a precast concrete boardwalk system, provide that information to you, the designer, if that's your role on the job. That then can be the basis of design on the boardwalk, and that can be the how your specification is written. And then there could be an allowance to go with an alternate to that. So a or equal could be used on that also. Other boardwalk suppliers, other boardwalk engineers, it may be done differently. And I suppose you'd have to ask them how they could contribute and help you through that process. You may have to hire structural engineers to design with a Trax boardwalk system, for example, if that's what you choose is the best solution.
Okay, perfect. And then we also had a question on just geotech scoping. Could you give us more guidance on what you need to include? How many bores would you want? Kind of for let's say a really large project and maybe a smaller project. What are we looking for, or what do we need from a geotech perspective?
Yeah, John, I'll start with that. And John Pyle's got a lot of experience to it. He might want to ask also, or answer to it also. Let's consider a very typical average size boardwalk. 100 to 200 feet long is very common. And when you approach the geotechnical engineer, I would highly recommend that first you understand what the loading is that you're trying to design for. Look at a range. Look at a range of how big can your spans be. Are they 10 to 20 feet, 30 feet? Determine what that range of loading is. You certainly don't want the geotechnical engineer to come back with a state DOT steel pile that's only good for a 100-ton pile. That's way too much. So match the loading with the soil capacity. So what do you ask the geotechnical engineer to do? Take these loads, provide for us, the designer and the boardwalk engineer, give them design recommendations. For example, let's have them evaluate, can the boardwalk be built with a shallow foundation system? Yes or no? If yes, give us an allowable bearing capacity of what that footing can be designed for. If that option is ruled out and it needs to be a deep foundation system, make a recommendation on what regionally is a good material for the pile foundation system. And then also provide some guidelines on what the skin friction is, what the end bearing is on the pile system. And sometimes geotechnical engineers will actually run a lateral pile analysis, which is sort of an extra, I would say, on some geotechnical reports. You don't always get that, but if you're willing to spend the money, that would give you what some of the lateral capacities are on a foundation system if the geotechnical engineer recommends deep foundation system. But the report should be concise. It should be specific to the boardwalk. Now, how many borings do you have to do? If you're a 100 or 200 foot boardwalk system, I would say as a minimum, I would do 2, maybe 3 borings on something like that. But I would leave it up to the geotechnical engineer to potentially say we might need more if you're getting a large variation in the number of pie and the soil profiles. You may very much get very drastic results different from one side to the other. And we've seen that happen where that doesn't play out very well for the owner. So have some more done. I would think on a 100 or 200 foot boardwalk, you shouldn't need any more than 5 or 6.
Okay, great. And sticking with foundation questions, just a couple more related to foundations. What do we kind of see as the most common foundations that are used in wetland environments? Do we know if the Army Corps of Engineers has specific foundations that they prefer to use? And then there's one specifically on vinyl coated timber, so maybe we could talk to that as well. So those kind of, what are our experience with wetlands as far as the common types of foundations used, and maybe touch on vinyl coated timber.
Sure. Foundations and wetlands has largely been successfully done with helical piers. I'll give the credit to the helical pier industry there. They are small, they're light, they can be installed with light equipment. The sticks of the helical pier are 5-7 feet long. They can be advanced quite easily if the soil is correct, suitable for it. But largely, a wetland is probably going to be softer soils, right, just by nature. So those work very well, and they can be installed from top-down construction. The question about vinyl coated piles is a good option to protect and improve the lifespan of the timber pile. And I've seen that been done, and you see that around boat docks, right? You see that all the time where you have the water rising and falling and exposing that timber. And that's where the timber gets in trouble, from a longevity standpoint. So protecting it with vinyl, absolutely, I would think that would be a good option. Yes.
Okay, great. We had a question around handrail. We were talking about the requirement of handrail over 30 inches. 1 to 10, he asked, do we need handrail like in a natural area or a natural area trail, like out, in the woods? Is that requirement still going to hold out there? Do we have flexibility there?
You mean if it's higher than 30 inches and you're out in a natural environment?
Right.
It depends on if you're trying to design, I think, and meet the ADA compliant rules. Or if you have a local jurisdiction who's the agency who's going to be responsible for it, or the owner, it's still a fall risk. And so most owners don't want to take on that kind of liability, or for having a structure that's greater than 30 inches above grade, and then have, heaven forbid, somebody falls off and gets injured. And then they would be potentially held liable for that, for not providing that kind of public safety. So my personal recommendation would be, if you're more than 30 inches, it's always a good idea to include a railing. And that's where the decision on what type of railing might be come into play. If you're out in the woods and you think you need railing, then you probably want to choose one of the least expensive types so that you're not putting a lot of money into your railing, since it's out there where it may not be seen that often. But it's always good practice to have a railing.
Absolutely. Yep. Perfect. We have a question here on the typical depth of planks. Can you just kind of go over the basic geometry of our standard components like the treads and the beams?
Yeah.
Sure, I'd be happy to do that. Yeah, the planks themselves are going to be either 4 inches thick or 5.5 inches thick. They begin from widths. Remember the clear width. So let's talk in terms of clear width. For a clear width of say 4 feet, the plank would be 4 inches thick. It would run up to about 8 feet, and then it would be increased to 5.5 inches thick. If you remember, that's because of the loading requirements for that width of boardwalk. The planks themselves can go up to about 15.5 feet in one piece, and that would be 5.5 inches thick. Heavier loading sometimes requires 6, 7, or 8 inch planks, but those would be non-standard pieces. But forms that we own do allow us to go to those thicknesses quite easily, but we wouldn't call it a standard piece. So 4 and 5.5 are your standards. In the lay lengths, in the direction, if you're standing on the boardwalk, walking down the boardwalk, those begin at 10 inches and they go upwards of say 4 feet, and they could be anywhere in between. But commonly, we'll see 2, 3, and 4 feet in length. The beams themselves, we have 2 different beam series there. We have a small beam series, which would simply be 9.5 inches tall. Our medium beam series is 14 inches tall. And then, of course, when we get larger than, say, 24 feet, the beam depth and width becomes a custom beam that, again, our forms are flexible where they can be accommodated to span those distances. And we've gone as large as 50-foot spans, but the thickness may be 27 inches thick for something like that.
Perfect. Thanks, Jason.
Sure.
Then we had a question on if we're under 30 inches, is a curb required? John, you want to touch on that?
It's my understanding that a curb is not required if you're less than 30 inches. Again, I go back to thinking about those beach access, dune crossovers. A lot of those, there's nothing on the side there. I think the 30-inch and less and having a curb on there is user preference, is owner preference. It's always good practice, but it's certainly not required.
Okay, great. And then the next question is around kind of typical square footage cost for kind of concrete systems in general. John, you want to kind of talk through that?
Yeah, and so a square footage cost. So when I think of in terms of a square foot cost for a boardwalk, I always build out an estimate based on the total cost. So it's the material of the boardwalk, the foundation cost, the contractor's installation cost, and then the railing. So the material of the boardwalk all by itself, concrete versus wood versus composite, really only tells part of the story, because the foundation, if as you're changing the span and the space between piers, you could have twice as many foundations for one system compared to another system. So I always look at it kind of on a broad level. The other thing that impacts that is the overall total scope. So larger projects tend to have a lower dollar per square foot because you're able to distribute some of those fixed costs over a bigger area. So the foundation has a very large impact, and we have an article on our website that takes you through the different estimated square footage cost. How much does a boardwalk cost? You can put that into the search bar on our website. So depending on the foundation type, that can be anywhere from $70 a square foot to $150 a square foot. And the variable there that you'll see is the foundation type. So that's why it's so critical that you get a geotechnical report early, so that you can make a good decision on a foundation type. And then that may impact, if it's a more expensive foundation type, you may want to use a custom beam design and go to 30 foot, even though your precast cost is now higher. In the end of the day, you actually saved money because you reduced that expensive foundation. And those could be $10,000, $15,000 per pile. So if you cut half of them out, even though, again, you spent more money on your precast, you actually, at the end of the day, delivered a lower total cost for the project.
Okay, thanks. Yeah, thanks so much, John. That was great. So we had a specific project question where, let's see, the water was diverted under a boardwalk and washed out some of the foundations, exposing a section of the helical piers that were not protected with concrete. How severe is this issue, and is there a best practice for both repair and preventing the issue from occurring again? So essentially, we've got some scour or erosion related to some water drainage underneath a boardwalk, and it's exposing the helical piers. And so, how big of a deal is that, first of all? And then what do we do to either repair it or prevent it from occurring? Or both, I guess.
Who wants to take that one? Me or you, Jason?
You can take a shot, John, if you want.
I will take a shot. So I think that the trick there is, I think what John just referred to it as a scour. It's a scour concern, and so that's part of the foundation design that we don't typically get involved with doing the scour analysis, but somebody on the design team should. So the consultant should be considering if you're near a waterway area, it's a kind of a complicated analysis. You have to run. Generally, the best way to do it is using something called HEC-RAS, which is a specific software that will model the stream. And based on the type of soil and the velocity of the stream, it'll calculate what your expected scour depth is. And so you want to have that foundation designed such that if that anticipated or calculated scour happens, that your foundation is still going to be stable. But we recognize that doesn't always happen. Sometimes scour, you get surprised and it comes out. So in this scenario, it would be good for a structural engineer, I think, to inspect that location to see what kind of damage has been done. Obviously, the pile has had some capacity, has been degraded. There may be a couple of ways of fixing that. It depends on the type of foundation. You may be able to pour a concrete collar around that to help beef it back up, but then you'd want to put soil back and riprap protection so that it doesn't happen again. That's a complicated one. I would definitely recommend getting somebody, a qualified structural engineer, to go out and evaluate that one in the field and give you a better recommendation than me off the top of my head without having seen it.
Perfect, great, thanks. Sorry?
Is there anything to add, Jason? You thought?
No, that was well done, John. No, I think that's a good answer.
Perfect. Then just a quick question on: do we have an Illinois licensed structural engineer on staff, or how do we in general deliver drawings and stamp drawings, that kind of thing?
Yeah, we do. We have access to a professional engineer that stamps our projects in Illinois. Yes, sir.
Perfect. Oh, hey, Alex Krosky, let's go. What's the distance that can be placed in a day? Yeah. Okay. So, do we need are there qualifications that a contractor needs to have? Do we have certified contractors to install the material? And what do we see as far as typical installation rates on projects?
Well, we do not use like certified installers or a network of installers necessarily. The system's designed so that it can be installed by a qualified civil site contractor. It does not require special bridge knowledge or anything like that. And we do have a field consultant that we send out at the start of a job to work with the contractor. A lot of our systems are installed by first-time contractors. So we want to make sure it goes well, that they have a good experience. The owner has a good experience. Everybody gets what they were expecting. So we send a field consultant out to help train somebody if they're not familiar with installing our system. But really, a contractor, if they're a qualified, competent contractor, we can train them to become a certified, if you want to call it that, Permatrack installer.
Perfect, perfect. Well, thank y'all so much. Thank everyone that is still on the call. That is the end of our list of questions, I believe. And we will call it a webinar now and wrap this up. So again, hope y'all have a great afternoon. And if you have a future boardwalk project that you're want to consider permatrack for, please reach out to any of us anytime. We'd be happy to work with you. You have a good one. Thanks.
Thanks, everybody.